Thanks, Serena, and welcome everyone today. So today I'm going to take us through the architecture paradigm that's underpinning the development of LLM-powered applications. But before I start on that, I did just want to recap a couple of points from Serena's presentation. So the first of these is we saw an example of a supply chain use case. But we've learned that these LLM-powered applications differ from traditional applications, both in their design and their capabilities, but they also have a huge amount of potential differentiating impact for a given organization. The second is that it's unlikely that any company or any business will just need to create one of these applications, but will need to have many and scale them across the enterprise to realize that true potential. So what I'm here to talk to you about today is how we get to that point and the architecture paradigm that underpins the development of these applications. And in order to do that, we first need to start by looking at the components that sit under any LLM-powered application. And we split these across 4 main levels, the first being data, services, logic, and application. The application layer, of course, being where the user will come in to interact with whatever sits underneath. Some of these components will be LLM-specific, and some of them are more traditional, that have been core to application development for years. So it's no surprise that we'll start at the bottom with our data layer and our structured and unstructured data. So this is our internal sales, product, and proprietary information that is providing that differentiating factor today between you and your competitors. But there is also another aspect that we can consider being at this data layer, and that is the large language model itself. So why can we consider the LLM to be part of the data layer? Well, when you think about it, an LLM is comprised of millions or billions of parameters that determine the makeup of how that model behaves. In some models' most recent releases, they can be multiple terabytes large. That is a huge amount of data to manage. And of course, these LLMs need to be interacted with, and therefore they needed to be hosted. And that brings us up to the the service layer with LLM services. Either you can host these models yourselves, or you can use a cloud provider or services provider such as Bedrock or OpenAI. Keeping on this service layer, we also have another LLM-specific component, which is retrieval services. For those leveraging RAG or retrieval augmented generation services today, it all fits into this bucket. It's where we're looking through our unstructured data to provide contextually or semantically relevant data to enrich a response or a query back to the user. And that brings us to more of our traditional components, such as data querying services. Essentially, this is our database. We're writing a query, we're getting a response back. The final aspect is a much more general term, API services. And this really could be a number of things. It could be an outcome from a model, forecasting or prediction. It could be internal or external data, such as CRM or ERP systems. Or external, such as social media analysis, weather data, or anything else that's going to help enrich the data that you have internally. Both of these more traditional services can then be rolled up into what we call tools when talking about LLM-specific applications, because the services are going to use the right tools in your environment to solve a specific problem. Still on this logic layer, we now have prompts. For anyone unfamiliar with prompts or prompt engineering, it's the way of interacting with your model, the same as anyone does with ChatGPT today. It's how you structure, phrase, and ask your questions so that you get the most appropriate response back. And we're fast seeing prompts becoming the new code base within any enterprise organization that's looking to leverage generative AI. They still need to be refined, they still need to be approved, and they still need to be managed and updated as any good code base would. But you can see there's also something missing from this component stack, something that ties all of these different objects together. And this is agents, as we heard earlier with Serena. Agents are a core component to any LLM-based architecture. It's relatively new within the enterprise IT landscape, but it's really forming a core component. It's that central orchestration layer that determines the autonomy of your application. So really, it takes a problem and it finds the appropriate tools in your environment to solve that problem. All of this is then presented to the end user via an application. Now, of course, depending on the use case, depending on what it is you're trying to build, the various components within this stack will change on an application-by-application basis. But this is what we see as the traditional stack as part of an LLM-powered application. What we've also learned from earlier is that it's unlikely we're going to want to build just one of these within our organization, but instead many. And in order to look at this, we need to not just consider the components of one application, but the architecture paradigm of how we build them all. And for that, we want to look at the architecture and how application development has changed over the last 20 or 30 years. So looking back, application development was, of course, very monolithic. It was one big code base that determined everything about your software, everything about your application, from data access, data querying service, visualization, and much more, all in one big code block. And at the time, this was absolutely fine. But as applications started to become more complex, as we started to scale up the number within a given organization, it became impossible to manage and scale. And this led the evolution to a more service-oriented architecture. Rather than having one big code block where everything was defined, it was separated into separate services that still communicated but could be managed separately. And that now brings us to the current architecture paradigm, the cloud-native version, which is the microservice architecture, a series of loosely coupled services that still communicate but are able to be managed, scaled, and updated, enabling organizations to really scale out the use of applications throughout their business. So this must be the way that we're developing LLM-powered applications today. Well, not really. We're traditionally seeing this coming back to the more monolithic approach, building everything in one go. If we take the example of a more advanced agent development, you typically see they might import LangChain. They might Google some code or ChatGPT some code. We'll chain some things together, run some other processes, and success. We have a working POC. And today, again, this probably is the quickest way to start proving value from LLM-powered applications. It's the quickest way to start showing that these kinds of use cases can provide value to your organization. But as with traditional applications, this will start becoming more complex as we look to scale and update and manage it. And it is just not a great foundation for scaling this type of architecture across the enterprise. So let's pop back to our component stack and the example Serena gave us earlier of our supply chain use case. We have developed this POC internally, and it has been a huge success. Other parts of the business have seen it, and they want you to now build this out for them. Or maybe they want to start building it out themselves. So your organization starts to add in more agents, add in more applications, starts chaining these various components together, and you end up with a bit of a mess. How do you manage and govern something like this? How do you understand where all of the costs are coming from? And what happens if we want to switch out one of these components for something else? You end up managing this huge spaghetti-type mess. And it's worth noting that different organizations will be able to handle a certain level of complexity. Some will be able to take more than others. But what is a standard is that as you add more LLM-powered applications, that complexity will continue to increase. And it's not a simple +1 application, it's +1 level of complexity, because you need to integrate these into your ecosystem. You need to manage the dependencies. You need to manage the connections. So we see this not as a linear scale, but generally increasing. And no matter what, at some point, every organization will reach this threshold where you can no longer create new applications, but instead spend your time managing, maintaining, and updating the existing stack that you have. But we heard before that these are the type of applications that are creating value and differentiation for a given organization. So what we need to do is see how we can try and raise this complexity threshold to enable the development of more applications and more value. And the way we do this is by shifting the architecture paradigm of how we build these LLM-powered applications, and not simply looking at how we build one or two, but how we scale this across the entire enterprise. And that new architecture paradigm is what we call the LLM mesh. The LLM mesh is a core principle with three main factors that underpin its development and should allow organizations to scale the use of generative AI across their business. The first of these pillars is to create an abstraction layer through which we access all of the services, LLM, retrieval services, everything. We should never be connecting these directly into the logic of the application layer itself. That only adds in more complexity. It makes you less agile. The second is to provide a federated services layer for control and analysis. Due to the non-deterministic nature of LLMs, it is very difficult to try and predict the cost and the performance when comparing to traditional applications. Therefore, it's increasingly important to have this services layer to give you that visibility and control as you scale. And finally, an LLM mesh should provide centralized discovery and documentation, not just for those end users, not just for the developers of the applications, but also for those agents that we learned about within the environment that need to find the right tools to be able to accomplish a specific task. And by adopting these three principles, it will allow organizations to move from the LLM mess to the LLM mesh. Firstly, by building out this catalog and gateway through which we can access all of the services we've seen in our component stack, retrieval services, tools, prompts, everything. At the top, we then have our federated services layer. Although different applications will have different reasons that they're being built for different parts of the business, they might be internal, external, there are some core principles that will sit above all of them. No matter what application, no matter what agent you're creating, they will always need to have some type of access control. They will always need to have some content moderation, maybe PII or toxicity. We'll always want to have visibility of the cost and performance and relevance, and therefore this is a core part of the LLM mesh. Once we have these components, your organization is then free to be able to build out your applications in a modular, scalable, and controlled way. And really, what this does is give you power and control over your AI future. It will allow you to maintain the choice and optionality amongst AI providers and the various tools that we'll have in the environment. There is a huge amount of development still going on in the generative AI world, and you need to be able to have that flexibility. We want to be able to mitigate risk by providing that end-to-end view across your entire stack. We want to be able to enforce policies and maintain that control and governance. And of course, we want to have a view and be able to reduce our costs by providing more modular components and building out applications in a much more efficient way. And this LLM mesh and this standard architecture is something that we believe very strongly in at Dataiku. It's something we've been working on over the last couple of years, and we feel so strongly about it that we are writing a book that will be out in early 2025. The first chapter is already available via the QR code, so if you want to get a sneak peek, please feel free to download. And there will also be some more chapters becoming available before the final release date in 2025. So before I leave you, I just wanted to note that, of course, you will not be surprised that Dataiku has our own out-of-the-box LLM mesh as a part of the platform. This is a core part of our product roadmap because we believe the LLM mesh will be foundational to enterprise looking to scale out generative AI applications across the enterprise. I won't go into this into too much detail because you'll be hearing a lot about it later today. But again, you'll see this come back up again. And with that, I'll say thank you for listening to me, and it is my great pleasure to welcome up on stage System 1, who will be talking about putting many of these AI practices into practice.